Hello, good morning. So excited because we're about to start Unit 4. I love starting new units. This lesson here. There's a lot of good stuff in this unit, but it starts out with kind of review. So let's just do a quick review of basic chemical reactions. I'm going to bring up some things to make sure that you're aware of, and try to not keep it so basic, but in looking ahead at your work, it's pretty simple. Okay. Now we do know that in chem reactions, that's how I abbreviate reactions, bonds broken and or formed. You know this. And in physical changes, such as phase changes, we are dealing with IMFs being formed, overcome, or weakened. Okay, that's an or. It doesn't look like it, but that says or. You should know this. You should know this. Okay, and you know that you're, solid to the liquid, liquid to solid. I'll just do this example. Solid to a liquid, solid to liquid. Well, that is obviously melting, and I must add heat. So that is an endothermic process. Heat is added, okay? If I want to take the liquid to the solid, I must remove the heat. So that is an exothermic process. And you should be able to figure it out for the rest of the phase changes. In this scenario here, let's see, I'm weakening IMFs. Right, I have not totally overcome them. And in the liquid to the solid, I'm forming IMFs, right? So that's where that energy is going. This energy is being put into the system to weaken the IMFs. This energy is being released from the system, allowing IMFs to form. All right. So, all right, I'm going to leave that at that. Now let's look a little bit closer at chemical reactions. And a lot of this is like writing some balanced equations, which you guys should be able to do because it's all over the summer packet, right? Let's just look at a couple that students often mess up. All right. So let's have a carbonate react with an acid, right? So let's say that we've got sodium carbonate reacting with, let's say, hydrochloric acid. This could be solid. It could be aqueous. We'll make it solid. Acids are aqueous in nature, okay? Unless they're extremely concentrated and there's no water in it, then it would be a liquid, but that's very rare. Okay? Now, I want you to think about this. Actually, well, no, I want you to think about this. So if you were new, right, if you were first year, Miss Murphy would say, oh, what type of reaction? We're going to have a double replacement reaction. Our cation anions are going to switch partners, right? So it'd be like, okay, sodium is going to go with chloride. That'll give us sodium chloride. And if we've got water present, that's definitely going to be dissolved. And then we would put the H with the the cation with the anion, and would give us H2CO3. Well, when this reaction occurs, I'm going to see bubbling. All right. And what that means is I've got the formation of a gas. And if you look at my products right now, neither one of them is a gas. So this chemical equation cannot be the end. This is not accurate. It's not fully accurate. So what you need to realize is that this further decomposes to make this. So we don't want to write this. We want to write this, because that is the reaction that occurred, and it shows the gas that was formed, that we know was formed, right? Let's do another example. Let's say that we take baking soda. Let's see if Miss Murphy can do this correctly. NaHCO3, baking soda, and we add it to vinegar, which is just acetic acid. You know that one, right? It's your volcano, right? You did in middle school. Make a volcano. You know it bubbles. So what are we going to get? Sodium will go with our acetate. Anything with a group 1A or with an acetate will dissolve in water, and we do have water present. Now we've got the H going with HCO3, which once again would make H2CO3, but it's really going to make water and carbon dioxide gas. And it's all balanced already. It's all balanced. Okay, so you need to remember your job is when you have a carbonate reacting with an acid, you're going to end up with the water and the carbon dioxide over here. You're going to have gases produced. Another common mistake that I see students do is a metal reacting with water. Okay, so let's see. Let's say that I've got sodium metal and I react it with H2O. And it is definitely quite a reaction, right? And we know it liberates a gas. Now I'm going to do this the wrong way. So if wrong ways confuse you, you may want to just fast forward for a minute. But students will look at this as a single replacement reaction where the sodium takes the place of the hydrogen and the sodium goes, oh, look at that arrow. And the sodium goes with the oxygen. And they'll go Na2O plus H2 gas. That is not what happens, all right? So if you remember when we learned, or you may not have been in my class, when you look at water reacting in this way, I like to see it as HOH, all right? Now we see that the sodium is going to take the place of the hydrogen as we initially predicted, but he's not going to be with oxygen, he's going to be with hydroxide. This will be in the solution, and then the gas will be produced. All right, and we would need to put a 2 here, a 2 here, and a 2 here. This is very basic, which you're not expected to know yet, but it's basic due to this OH, okay? So we end up with a very basic solution, right? We just started with water and a solid metal. We now have a very basic solution, and we've released a lot of gas. Okay. All right, so we could do that again, where we have calcium metal plus water would give us this time calcium with hydroxide, and that's going to be CaOH2. It's slightly soluble, slightly insoluble, and hydrogen gas. So this time we would just need a 2 right there. Still basic, right? We still have a basic solution, and we produced a lot of gas. So there's your small explosion, right? Basic. So that is a trend that occurs. And one thing you can go ahead and put, oops, that's not pretty. One thing you can go ahead and realize, we'll probably bring it up when we talk about acids and bases, is metals, I'll write it, metals plus water yield basic solutions. Okay, so you should know that. Metals and water yield basic solutions. So metal oxides are basic and non-metal oxides are acidic. If you want to think about that, right? Where's your non-metal? There's your non-metal oxide. Oh, well, look what we might end up with here. Don't worry about balancing, right? We could figure that out later. Don't need to worry about it. Let's take this guy, put it with some water. Oh, let's look at what we might get there, right? And let's look at another one, CO2 plus H2O. Oh, look. So what we see here is that non-metal oxides yield acidic solutions, right? Whereas metal oxides, let's see if I can do this without messing it up. Yeah, right? Don't look at it as H2O. Look at it as HOH, right? Well, he's going to go with him. I'm going to make my sodium hydroxide and H2O. All right. Okay. So your non-metal, right? Let's non-metal oxides here. Your non-metal oxides give us acidic solutions, whereas our metal, right? This is my metal oxides plus water yield basic solutions. I already wrote this. I just wrote it again. And I'm going to leave that there. Okay, I'm just going to highlight it to make it look pretty. Metal oxides, basic solutions. Okay. The rest of this topic 4.1, we've covered, and it'll be a review for you. Okay. Yay. Let's go ahead and stop and get ready to start the next video. Bye.